How ancient Egyptians really built the Great Pyramid. Imagine standing on the Giza Plateau more than 4,500 years ago. There is no Great Pyramid, no endless wall of golden stone rising above the desert, no famous silhouette against the Egyptian sky. There is only a vast construction site, the sound of copper striking limestone ropes, tightening wooden sledges, grinding forward, and thousands of workers moving with astonishing coordination. Before them lies a task that seems impossible, even today. Build a monument nearly 150 meters high, align it almost perfectly with the four directions, and assemble it from roughly 2.3 million stone blocks, some weighing several tons, others far more. They have no engines, no steel cranes, no trucks, no modern surveying equipment. So how did the ancient Egyptians do it? The honest answer is that no surviving document explains every stage of construction. Archaeologists have found tools, workers, settlements, quarries, transport records, unfinished monuments, ramps, and images of heavy objects being moved. Together, these clues reveal most of the system. The pyramids were not built with one magical invention. They were built through planning, organization, river transport, skilled labor, simple machines, and an enormous understanding of stone. The story begins before the first block was placed. Pharaoh Khufu chose a limestone plateau at Giza, west of the Nile. The location offered two enormous advantages. It stood high enough to dominate the landscape, and much of the stone needed for the pyramid could be quarried directly from the plateau itself. The builders first had to prepare the foundation. A structure as massive as the Great Pyramid could not stand on loose sand. Workers cleared the area until they reached solid bedrock. They cut away high points and filled low sections, producing an extraordinarily level base. How did they measure so accurately? Egyptian surveyors used simple but effective instruments, cords, measuring rods, plumb bobs, sighting tools, and careful observations of the sky. To establish straight lines, they could stretch cords between fixed points. To test vertical surfaces, they used weighted plumb lines. To create right angles, they relied on geometry developed through generations of land measurement. The pyramid's sides were aligned extremely close to true north-southeast and west. Scholars still debate the exact method, but the Egyptians may have observed circumpolar stars rotating around the northern sky. By tracking pairs of stars or measuring their movement, surveyors could establish a reliable north-south line. Once the site was marked, quarrying began. Most of the core blocks did not travel hundreds of kilometers. They came from local limestone quarries close to the pyramid. This reduced the greatest problem in the entire project: transportation. Workers opened channels in the rock around the block they wanted to remove. Copper chisels and stone tools shaped the softer limestone. Wooden levers helped loosen blocks from the bedrock. Harder pounding stones, often made of dolerite, could crush and shape tougher surfaces. Copper was not as hard as modern steel, so tools wore down quickly. But that did not make them useless. Egypt had specialist metalworkers who sharpened, repaired, and recast tools. The construction site was supported by an entire industrial system: miners, supplying copper, carpenters, making sledges, rope makers, twisting plant fibers, bakers, producing bread, brewers, making beer, and administrators recording deliveries. The pyramid was not simply a pile of identical blocks. The rough inner core used large quantities of local limestone. The smooth outer casing required fine white limestone from Tura across the Nile. Granite used in important internal chambers came from Aswan, hundreds of kilometers to the south. Some of those granite pieces weighed dozens of tons. This is where the Nile became Egypt's greatest machine. During the annual flood season, the river rose and spread through channels closer to the desert edge. Boats and barges could carry stone far more efficiently than workers could drag it across land. One of the most important discoveries in pyramid archaeology is the Diary of Merer. Written by an official named Merer near the end of Khufu's reign, the papyrus records the daily activities of a crew transporting fine limestone from Tura to the area of the Great Pyramid. Merer describes teams loading stone, traveling by boat, stopping at administrative points, and moving through waterways connected to Giza. His diary does not explain how the blocks were lifted to the top, but it proves that pyramid construction depended on carefully managed transport networks. Picture a cargo boat moving north along the Nile. Its deck sits low in the water beneath heavy limestone. Sailors watch the current. Officials inspect supplies. At Giza, the vessel enters a harbor or canal basin near the construction zone. The blocks are unloaded, placed onto wooden sledges and prepared for the next stage. Now the stone must cross the ground. For generations, people imagined that the Egyptians rolled blocks on logs. But logs would have been valuable in a country with limited large timber, and rollers become difficult to control under enormous weight. Wooden sledges offer a more practical solution. Ancient Egyptian art shows teams pulling giant statues on sledges with ropes. In one famous scene, a person pours liquid onto the ground in front of the runners. Modern experiments show why this matters. Dry sand can pile up in front of a moving sledge, increasing resistance. With the correct amount of water, the sand becomes firmer, and the sledge can move more easily. The workers did not need to flood the route. Too much water would create mud. They needed controlled moisture enough to bind the sand grains and reduce the force required to pull the load. A foreman would coordinate the team. At a signal, dozens of workers leaned into thick ropes. Others stabilized the block, cleared the path, adjusted the sledge, and carried replacement ropes. Rhythm mattered. A badly timed pull could waste energy or cause the load to slide sideways. Songs or shouted commands may have helped the men move together. Transporting blocks horizontally was difficult. Raising them was the greater mystery. Most Egyptologists agree that ramps were involved, but no single ramp design has been proven for the entire Great Pyramid. A long, straight ramp is easy to imagine. Workers could drag stones upward as the pyramid grew. But to reach the highest levels at a gentle slope, such a ramp would become extremely long and would require a tremendous amount of material. A ramp wrapping around the outside would use less space, but it could obstruct the corners and make precise measurement more difficult. Another possibility is a system of multiple ramps that changed as construction progressed. Broad ramps may have served the lower levels where most of the stone was placed. Smaller side ramps, zigzagging routes, or platforms could have been used higher up. At the ancient quarry of Hatnub, archaeologists discovered a steep central ramp, flanked by stairways containing post holes. Ropes could be wrapped around wooden posts, allowing teams on both sides to pull a loaded sledge up a steep slope. Hatnub was an alabaster quarry, not the Great Pyramid itself, but the discovery proves that Egyptians of Khufu's era understood sophisticated rope and ramp hauling systems. The builders may also have used levers. A short wooden lever can lift one side of a block just enough to insert a support beneath it. Repeating the process could raise a stone step by step. Ramps and levers were not competing ideas. They could have worked together, ramps for major movement, levers for final positioning. As each layer rose, workers placed blocks, checked their alignment, trimmed surfaces, and filled gaps with mortar and smaller stones. The inner core was not finished with the same perfection visible in the chambers or casing. Precision was concentrated where it mattered most. Inside the pyramid, the challenge became even greater. The builders created descending and ascending passages, the Grand Gallery, the so-called Queen's Chamber, and the King's Chamber. Above the King's Chamber, enormous granite beams were stacked to form relieving spaces, helping redirect the weight of the pyramid. These granite beams had traveled from Aswan and weighed far more than ordinary limestone blocks. Moving them required stronger sledges, heavier ropes, larger teams, and carefully prepared routes. The internal chambers were not carved after the pyramid was completed. They were constructed as the surrounding mass rose. The builders had to know where passages would go long before the exterior reached its final height. That required architects, surveyors, scribes, and experienced stoneworkers working from a coordinated plan. Who were these workers? Popular films often show armies of enslaved people being whipped beneath the sun. Archaeological evidence presents a different picture. Near the pyramids, researchers found settlements, bakeries, food processing areas, administrative buildings, and burials connected with the workforce. The builders included permanent specialists and rotating labor crews. Some laborers may have been recruited as a form of service to the state, especially during the Nile flood season when agricultural work slowed. Their work was exhausting and dangerous. Skeletons show injuries, heavy physical stress, and in some cases healed fractures, suggesting that injured workers sometimes received care. They were organized into crews with names and identities. Graffiti found in hidden spaces inside the Great Pyramid records groups, such as the Friends of Khufu. These marks were not intended for tourists or public display. They were left by the people who handled the stones. The project may have employed thousands of workers rather than the impossible armies described in later legends. But the number at the construction site was only part of the story. Across Egypt, many more people supported the operation by producing food, wood, copper, rope boats, tools, and clothing. The true power behind the pyramid was not raw muscle alone. It was administration. Scribes tracked rations and labor. Officials scheduled quarry crews and boats. Surveyors checked dimensions. Skilled masons corrected errors before they multiplied. Food had to arrive every day. Broken tools had to be replaced. Ropes had to be inspected. Boats had to move with the seasons of the Nile. So a single stone might pass through many hands. First quarry workers cut it from the bedrock. Then masons roughly shaped it. Lever teams loaded it onto a sledge. Haulers pulled it to a dock. Boatmen transported it through the waterways. Another crew unloaded it at Giza. Ramp teams dragged it upward. Finally, setting crews positioned and trimmed it. Repeat that process again and again for years. The outer casing transformed the structure. Fine white limestone blocks were placed with great care, creating smooth faces rather than the stepped appearance seen today. When sunlight struck the finished pyramid, it would have reflected brilliantly across the landscape. At the summit, a capstone, possibly covered with a shining metal, such as electrum, though this remains uncertain, may have completed the monument. Then the ramps and temporary works were removed. Casing stones were finished from the upper levels downward, and debris was cleared away. Temples, causeways, subsidiary pyramids, boat pits, and surrounding tombs formed a complete sacred complex. The Great Pyramid was not only an engineering project. To the ancient Egyptians, it was part of a cosmic system. Its shape evoked the primeval mound, rising from the waters of creation and perhaps the rays of the sun. It served the royal cult of Khufu and was designed to secure the pharaoh's transformation after death. Every stone was placed within a society where religion, kingship, agriculture, taxation, and engineering were deeply connected. So did the Egyptians use a secret lost technology? Probably not. The surviving evidence points to something more impressive: familiar tools used on an extraordinary scale. Copper instruments, stone pounders, wooden sledges, ropes, boats, water, ramps, levers, mathematics, astronomy, skilled hands, central planning. No single method solves every part of the puzzle, and the exact shape of the pyramid's upper construction ramps remains uncertain. But uncertainty does not mean magic. The Great Pyramid could be built because the Egyptians broke an impossible task into thousands of manageable tasks. They placed quarries beside the site. They used the Nile as a highway. They reduced friction with sledges and prepared surfaces. They raised stones through ramps, ropes, and leverage. They divided workers into specialized teams, and they supported those teams with one of the most organized states of the ancient world. The pyramid looks like the work of giants because we see it as one object. The builders saw it differently. To them, it was a sequence: one measurement, one shipment, one pull, one layer, and one block at a time. And after decades of labor, the final stone was set. The ropes fell silent. The workers stepped back. Before them stood a mountain made by human hands, a monument so precisely planned and so powerfully built that more than 4,500 years later, it still forces the world to ask the same question: how did they do it? The answer was never aliens, magic, or impossible machines. It was knowledge, organization, and people.